Hello, geometry students. This is Mr. Fugay, and this is the first part of a two-part video where we are going to talk about the sector area and arc length of a circle. Now, for this first video, we're going to be exclusively working with degrees as our measurement for angles, and video 2 will take a look at these same perspectives from the radian perspective. So let's go ahead and get started. And before we start talking about sector area and arc length, we have to first talk about area and circumference. So, as a refresher, take a look at these two boxes where they talk a little bit about both of these and what they measure. So area is a square dimension, a square unit, as it is looking at a two-dimensional space that we are measuring. And the formula we use for that is pi r squared. And then for circumference, circumference is another word for the perimeter or the outside length of a circle. So basically, if you took the circle outside edge, lined it up in a straight line and measured it, that would be its circumference. And the most common formula that most people know is the formula 2 pi r. There is the alternative pi times diameter. You can use that, but honestly, I usually just use the 2 pi r when we go through this. So if you look at examples 1 and 2, this is going to just be a very straight up formula manipulation problem where you're going to use the formulas in their respective ways, plugging in the information you have and finding whatever it is you need to find. So for example 1, it's asking to find the area and circumference of a circle, but the diameter, and that's going to be the key here, is 10 inches. So if we use the two formulas that we just talked about, we have pi r squared, and circumference is 2 pi r. Now technically they did not give you the radius, but just a reminder that the diameter is the length across the circle where it goes through the center, and therefore the radius is going to start at the center and go to the end. So what you should hopefully see from that drawing there is that the radius is actually just going to be half of whatever the diameter is. So in this case, it's going to be 5. So to figure out both of these measurements, we're going to take r and make it 5, and we'll simplify that in a second, and this becomes 2 pi times 5. Now this is as easy as just putting it in your calculator if we want to get a decimal answer. If we want to get an answer in terms of pi, that essentially means we are not going to multiply pi into our answer. So we're just going to do all the operations except pi. So in the case of the area, we're just going to do 5 squared, which is 25. We'll put that pi on at the end, which means the answer is going to be a little bit bigger than 75 square units, but keeping it in exact form, we're going to say it's 25 pi square inches. And the reason we do this ultimately is because if we're going to use this for additional work beyond finding the area, having it in terms of pi is going to be easier to do that next step with. For circumference, all you would do is literally multiply the 2 and the 5 together, so we would get an answer of 10 pi inches. So I want you to use this concept and use this idea to try example 2. So I'm going to go over it, but I want you to take a moment to pause this and see if you can try it yourself before I start going over it. So in this problem, they've given us the area as 50 pi, and what they want us to find is they want us to find the circumference. So we're still going to use both formulas, but we're going to use them just a little bit differently than we had used it before. So we have pi r squared, we have 2 pi r, and what we're going to do now is plug in what we know. So since we know the area in this situation, we'll go ahead and we'll plug that 50 pi where the a is. And so remembering that pi is just a number, and this is exactly why we want to write things in terms of pi when we have the ability to, because when I divide both sides by pi, had that been a decimal, we would have to go to our calculator and type in the crazy decimal, divide it by 3.14, get another decimal. But when we write things in terms of pi, I don't even need to pull out my calculator because I know that the pi's just cancel on both sides, and we're left with 50 equals r squared. And even at this step, when we take the square roots, this is not going to be a perfect square, but since 50 is equal to 25 times 2, and 25 is 5 times 5, we can write this in simple radical form as just 5 root 2. So keeping things in terms of pi is really helpful when we want to try to not use a calculator for our work. Now, we do have what the radius is. We found the radius here. We're now going to take that and we're going to plug it in to find our circumference. So this will be 2 pi. The radius is going to be 5 root 2. And just like we talked about, if we want to keep this in terms of pi, the 2 and the 5 are the only two things I can multiply. So we're going to say 10 pi root 2. Now, I typically like to keep the pi in the front because if I had wrote that afterwards, and I put it after this, it could get confused that that's inside of the square root when in fact we know that it's not. So what I do to try to avoid that is always write the square root at the very end of my expression, like so, and I've got to put my units on this. This is in inches, so that's going to be the circumference of our circle. Now, to finish up this area circumference review, I have a more thought-provoking question that is going to use these formulas to help you look at the size and deals that Crumbl Cookie offers. So this is all as of May of 2024, so it should say as of, not as off, as of May 2024, but they've just introduced these mini cookies to Crumbl Cookie, and I want you to take some time to investigate and look at the areas of these, that's how much cookie we have, and comparing them with one another to see how good of a deal the mini cookies are compared to the original. Now, I'm not going to go over them in this video. Rather, I'd like you to have this conversation in class, and I will be sure to let you know when we'll have that discussion and talk about it. But at this point, at least take a look at these problems, maybe pause the video, and try to answer these 3 questions to the best of your ability. Last part of our video here today, we're going to talk about now how to find sector area and arc length. So the first thing we need to know is what a sector area is. A sector is a part of a circle created by 2 radii and a central angle. So up in this diagram up here, we have our radii AO, our radii OB, and then this angle right here we measure, we'll call it theta, and for today's lesson we're going to talk about degrees. So that is going to be important. That theta is important because we know that an entire circle is 360 degrees. And so I don't want to find the full area of the circle, I want to find a partial area. So that's exactly the second part of this here. A sector is a fractional portion of a circle's area, and it is measured in square units as well. So to figure out the sector area, we have to first look, so we'll say SA for sector area, we have to first look at the entire area of the circle, pi r squared. And then if we want to find just a section of it, remember that this is a fractional part out of a total of 360. So theta over 360 is always going to give me the fractional amount that we're working with. So for example, if my theta was 90 degrees, we know that 90 degrees is exactly a quarter of the circle because the central angle is 90, the total degrees in a circle is 360, so that's why we're looking at 1/4 of the area. That's exactly what we're going to add to the back end of this formula and say theta over 360. And remember, this particular formula is in degrees. Now we're going to take this exact same concept and we're going to apply it into our arc length as well. So arc length, instead of talking about area, a fractional part of the area, it is a fractional part, but this time of the circle's circumference. And that's going to be measured as a linear unit. So circumference, remember, is the entire length of the outside edge of the circle. The arc length, we're only looking at a section of that. So once again, we're going to need to use that important number, theta, to basically tell us what fractional portion we're working with. And so arc length's formula is going to look like the circumference formula, 2 pi r, but then we're going to multiply it by that fractional part that we're working with. So in this case, theta over 360. And so we're going to use these 2 formulas now to help us find the sector area and arc length of a particular circle. So let's go down and look at example 4a. And let's first draw a picture of what this looks like. So first off, if I draw my center here, we know that the radius is 12. 45 degrees is going to, well, roughly look like about this right here. And so what we want to do is we want to first find the arc length of this sector. So we're going to find that blue length right here. That's my arc length. And then we're going to find the actual area of this. That's going to be my sector area. And those are the 2 things we're going to be measuring here. So let's start with arc length. Arc length is going to be 2 pi r times that theta over 360. Now we'll go ahead and plug in those numbers because we have all of those numbers in front of me. The radius is going to be 12. My theta is 45 over 360. Now at this point you really could just throw this in the calculator, but I want to talk about this because the 45 degrees, as you probably are seeing here, is going to be half of a quarter, right? So 90 degrees is a quarter of the circle. This makes 45 degrees equal to an eighth of the circle. So 1/8. So another way to think about this is, well, if we want to find the arc length here, we would multiply those together and say, well, that's 24 pi. That's the entire circumference of the circle. And then 45 over 360, well, that's just 1/8 of my total answer. So actually, if you look at like a piece of pizza that's cut up into 8 slices, each slice should be approximately 45 degrees. Well, if we multiply these numbers together, this is going to give me an answer of 3 pi, and this was measured in centimeters. So while the full circumference of the circle was 24 pi, since we were looking at 1/8 of the circle, the arc length ends up being 3 pi. We can take the same concept and apply it to sector area. So sector area's formula is the pi r squared, that's the full area, times that theta over 360. So when I plug my numbers in for this, once again, we know that the radius is 12, so we'll say 12 squared. So erase that and try that again, 12 squared, and then 45 over 360. Again, you could throw it in your calculator right here if you want at this point, but if we look at it from without a calculator, the full area of the circle is going to be 144 pi, and then what we're going to do is take the fractional part, which we said again is 1/8, so we're really just taking an eighth of the answer. And so in this case, my sector area is going to end up being about 18 pi square centimeters. That's going to be my final answer for that part of the problem. For the last section here, we're going to skip the things we've been skipping, we'll come back to in part 2. For the last problem I want you to try is example 5. In this case, I am going to give you the arc length of a circle. And then in addition, I am also going to give you the radius of that circle. And what I want you to do is to first find that central angle, find that theta that is going to form the arc. You don't have to do it in radians, by the way. We're going to do this in degrees. So let's write that in degrees. And then I want you to take that and find the area of the sector. So go ahead and pause this video and give that problem a try. So let's go over this. I don't have the problem fully done, but I have some steps put out because I want to talk about some of the middle steps of the problem. So we start with our arc length formula. We know the arc length is given as 16 pi. We know the radius is given as 12. So I substitute those things directly in, and then I went ahead and simplified my full circumference in this case, which is 24 pi. Now we want to figure out what theta is, and there's a couple different ways to go about this, but the easiest way, I think, in my opinion, would be to divide both sides by both 24 and pi, the number 24 pi, because what happens here is the pi's end up canceling there and they cancel there, so we really just have the number 16 over 24. Since both those numbers go into 8, that means that my answer is going to be 2/3. So my answer for theta kind of looks like a proportion here. 2/3 is equal to theta over 360. The easiest way to attack this is to multiply both sides by 360. So when I do that, we're going to get a theta value here of 240 degrees. And this is going to be an important number because that is the measure of the central angle. So if you wanted to get like a visual about what we were working with here, we would have our circle. Our 240 degree angle is going to probably look a lot like this. So the area that we're now trying to find is actually encompassed right there. And if you notice, that is approximately 2/3 of the circle. So hence why the 2/3 number was used in our problem. So we're going to take that and we're going to apply it over here to find sector area. So all we have to do now is plug in the radius that we already know, which is 12. We know our theta is 240 over 360, but I'm going to challenge you to just use 2/3 since that's what it simplifies to. So when we do this, we're going to end up with 144 pi times 2/3. And when I multiply those together, we're going to get an answer, a sector area of 96 pi. I believe this was done as units squared. So that's going to conclude part 1 of this video, which talks about arc length and sector area working with degrees. Be sure to try the practice problems associated with this section of the lesson. And then when prompted, we'll head on to part 2 where we talk about radians. Thanks for watching.